Hello everyone, my name is Sujit. Now I'm here to explain Border Gateway Protocol. Border Gateway Protocol is a standardized exterior gateway protocol designed to exchange routing and reachability information among autonomous systems on the internet. It is a path vector protocol and it is an exterior gateway protocol. And the selection of path is based on the link autonomous system, next to hope, local preferences, and MED value. The MED value is used to select the best entry point in AS2 while you are communicating from AS1 to AS2. Business policies, traffic engineering, and route selection are some local preferences values. Now let us see why we need to use BGP, that is Border Gateway Protocol. It is designed to work for big networks and a very large network, that is, for example, between two AS autonomous systems. And there is no hop limits like compared to RIP routing protocol. And it will use a complex algorithm for determining the best paths. Each router will have a complete view of the network, and it is also a reliable protocol. That means there is a guarantee of packet reach, and it supports classical inter-domain routing, which is CIDR, and it will also reduces bandwidth consumption. And before that, there are two types of BGP. One is interior border gateway protocol and exterior border gateway protocol. The administrative distance for exterior border gateway protocol is 20, and the administrative distance for interior border gateway protocol is 200. And there are total three routing tables in BGP. The first one is neighbor table. It will list all the directly connected neighbors of that particular router. And the second one is database table. It contains all the possible routes in the network. And the third one is routing table. It contains the best path, which is based on different flexible metrics. Let us discuss about BGP messages. The first message is open message. It will initialize the resources and sessions, like for example BGP version, autonomous system number, hold time, and some optional parameters. Once two BGP routers have completed a TCP three-way handshake, they will attempt to establish a BGP session. This is done using open messages. In the open message, you will find some information about the BGP router. This has to be negotiated and accepted by both the routers before we can exchange the information. And the next one is keep alive message. It will maintain BGP session or route and 60-second, one third of hold time. For every 180 seconds, we will send keep alive messages. And the next one is update message. If any new route or any changes in the path or path attributes, it will responsible to update to the administrator. Once two routers have become BGP neighbors, they can start exchanging routing information. This is done with the update message. In the update message, you will find information about the prefixes that are advertised. And the last one is notification message. It is responsible for terminating the system or any error in the messages or any error in the error code, or if there are happening any abnormal events in the system, then it will detect and it will notify. There are total seven BGP states. The device operating BGP goes through certain states. These states are: the first one is idle state, second one is connect state, and third one is active state, fourth one is open state, and fifth one is open confirm state, and sixth one is established state. Let us discuss about the states in the upcoming slides. The first one is idle state. It will initialize resources and wait for a response, and then it goes to connect state. Connection retry for every 120 seconds. This is the first state of BGP. BGP detects a start every TCP connection to the BGP peer and also listens for the new connection to peer router. In connection state, it will wait for three-way handshake to compute. If TCP connection is successful, then it sends open state message and changes the state to open state and it clears CR timer. If the TCP connection is not successful, then it will go to active state and it will reset the CR timer. If any BGP connection failure happen, it goes to the idle state. And the next state is active state. We all know that BGP states three-way handshake. If TCP connection is successful, it clears CR timer and sends open message and change the state to open state. If it fails, then it goes to idle state. Either of this will happen. If not happen, if connection timer expires, then it goes back to connect state. And the next state is open send state. It will wait for receiver to receive the message. Receiver will verify open message and send keep alive messages. Then it goes to state called open confirm. If verification is unsuccessful, then it goes to idle state. If any TCP failure happens, it goes to active state. And the next state is open confirm state. BGP waits for keep alive messages from its peers. If it's successful, it goes to established state. Otherwise, if it is not successful, then goes to idle state. And the last state is established state. There are three stages involved in this established state. The first one is there will be exchange of update messages, and the second one is there will be exchange of keep alive messages for every 120 second, and the connection timer expires. Then again, it will go to the idle state, and it will repeat the process of all the states. Now let us conclude this session by discussing advantages of BGP. Here are some examples of advantages of BGP. And the first one is there is no limitation on the hop count unlike RAP. And the second one is scalability. BGP allows the internet to handle the increasing number of connected devices and networks. And the next one is security. BGP helps identify and mitigate security issues like routing hijacking and leaks. And next one is troubleshooting. BGP routing knowledge helps identify and resolve routing problems. And the last one here we are discussing is network stability. BGP continuously monitors the paths and make dynamic adjustments to ensure uninterrupted network services. Okay, guys, let's end this session. Thank you for hearing up to the last of this video.